Big surprise from the edge of the solar system, presented by Science at NASA. NASA's Voyager probes are truly going where no one has gone before. Gliding silently toward the stars, 9 billion miles from Earth, they are beaming back news from the most distant, unexplored reaches of the solar system. Mission scientists say the probes have just sent back some very big news indeed. It's bubbly out there. The Voyager probes have entered a strange realm of frothy magnetic bubbles, says Marav Ofer of Boston University. This is very surprising. The bubbles are large, about 100 million miles wide, so it takes the speedy probes a whole year just to cross a few of them. Voyager 1 entered the foam zone in 2007, and Voyager 2 followed about a year later. At first, researchers didn't understand what the Voyagers were sensing, but now they have a good idea. The sun's magnetic field extends all the way to the edge of the solar system, explains Offer. Because the sun spins, its magnetic field becomes twisted and wrinkled, a bit like a ballerina's skirt. Far, far away from the sun, where the Voyagers are now, the folds of the skirt bunch up. When a magnetic field gets severely folded like this, interesting things can happen. Lines of magnetic force crisscross and reconnect. The crowded folds of the skirt reorganize themselves, sometimes explosively, into foamy magnetic bubbles. We never expected to find such a foam at the edge of the solar system, but there it is, says Offer's colleague astronomer Jim Drake of the University of Maryland. Drake says they are still trying to wrap their minds around the implications of the finding. One consequence has to do with cosmic rays. Cosmic rays are subatomic particles accelerated to nearly light speed by distant black holes and supernova explosions. When these microscopic cannonballs try to enter the solar system, they have to fight through the sun's magnetic field to reach the inner planets. The magnetic bubbles turn out to be our first line of defense against cosmic rays, points out Offer. We haven't figured out yet whether this is a good thing or not. On one hand, the bubbles would seem to be a very porous shield, allowing many cosmic rays through the gaps. On the other hand, cosmic rays could get trapped inside the bubbles, which would make them a very good shield indeed. We'll probably discover which is correct as the Voyagers proceed deeper into the froth, says Offer. This is just the beginning, and I predict more surprises ahead. For more information about places no one has ever been before, please visit science.nasa.gov.
The Power of Sea Salt, presented by Science at NASA. On Friday, June 10th, when a Delta II rocket blasted off from California's Vandenberg Air Force Base, rumbling into a morning blue sky atop a column of white smoke, some onlookers felt they could smell a hint of salt among the rocket's exhaust. Was it spray from the nearby Pacific Ocean? Or something to do with the payload itself? That rocket was carrying a sensor named Aquarius, on a mission to map the salt of our planet's seas. Researchers suspect that the salinity of Earth's oceans has far-reaching effects on climate, much as the salt levels within our own bodies influence our own delicate internal balance. This is why the Aquarius mission is so important. Based on decades of historical data gathered by ships and buoys, we know the salinity of Earth's oceans has changed over the last 40 years, says Aquarius principal investigator Gary Lagerlof, a scientist at the Seattle-based independent laboratory Earth and Space Research. Something fundamental must be happening to the water cycle. In some regions, like the subtropical Atlantic, salinity is increasing, which means more fresh water is being lost through evaporation at the sea surface. But no one knows why this is happening, nor can anyone pinpoint why other areas are experiencing more rainfall and lower salinity. To solve the mystery, scientists need a comprehensive look at the ocean's salt content. Within a few months, Aquarius will collect as many sea surface salinity measurements as the entire 125-year history record from ships and buoys. Circling Earth onboard Argentina's SAC-D satellite, Aquarius is one of the most sensitive microwave radiometers ever built, and the first NASA sensor to track ocean salinity from space. It can detect as little as 0.2 parts salt to 1,000 parts water, about the same as a dash of salt in a gallon of water. A human couldn't taste such a low concentration of salt, yet Aquarius manages to detect it while orbiting 408 miles above the Earth, says Lagerlof. Salinity, along with temperature, governs the density of seawater. The saltier the water, the denser it becomes. Density, in turn, drives the currents that move heat around the planet. For example, says Lagerlof, the Gulf Stream carries heat to higher latitudes and moderates the climate. When these currents are diverted by density variations, weather patterns such as rainfall and temperature change. Could salinity be prompting such changes? For answers, researchers look to the sky. Aquarius, they hope, will soon reveal the power of sea salt. For more salty tales of Earth science, please visit science.nasa.gov.
Wild Weather, What's to Blame? Presented by Science at NASA. Record snowfall, killer tornadoes, devastating floods, there's no doubt about it. Since December 2010, the weather in the USA has been positively wild. But why? Some recent news reports have attributed the phenomenon to an extreme La Niña, a band of cold water stretching across the Pacific Ocean with global repercussions for climate and weather. But NASA climatologist Bill Patzert names a different suspect, La Nada. La Niña was strong in December, he says, but back in January it pulled a disappearing act and left us with nothing, La Nada, to constrain the jet stream. Like an unruly teenager, the jet stream took advantage of its newfound freedom, and the results were even more disastrous. La Niña and El Niño are opposite extremes of a great Pacific oscillation. Every 2 to 7 years, surface waters across the equatorial Pacific warm up, El Niño, and then they cool down again, La Niña. Each condition has its own distinct effects on weather. The winter of 2010 began with La Niña conditions taking hold. A normal La Niña would have pushed the jet stream northward, pushing cold Arctic air, one of the ingredients for severe weather, away from the lower U.S. But this La Niña petered out quickly, and no El Niño rose up to replace it. The jet stream was free to misbehave. By mid-February 2011, the jet stream was meandering wildly around the U.S. The weather pattern became dominated by strong outbreaks of frigid polar air, producing blizzards across the West, Upper Midwest, and Northeast U.S. The situation lingered into spring, and things got ugly. Russell Schneider, director of the NOAA National Weather Service Storm Prediction Center, explains. First, very strong winds out of the south carrying warm, moist air from the Gulf of Mexico met cold jet stream winds racing in from the west. Stacking these two air masses on top of each other created the degree of instability that fuels intense thunderstorms. Extreme contrasts in wind speeds and directions of the upper and lower atmosphere transformed ordinary thunderstorms into long-lived, rotating supercells capable of producing violent tornadoes. In Patzert's words, the jet stream, on steroids, acted as an atmospheric mixmaster, causing tornadoes to explode across the Deep South and Tornado Alley, and even into Massachusetts. The action's not over. This is weather, after all. What will happen next? Please don't say La Nada. For more information about wild weather on Earth and other planets, please visit science.nasa.gov. An Astronomer's Dilemma: Finding Planets Among the Stars, presented by Science at NASA. Strange but true, when it comes to finding new planets, stars can be an incredible nuisance. It's a matter of luminosity. Stars are bright, but their planets are not. Indeed, when astronomers peer across light years to find a distant Earth-like world, what they often find instead is an annoying glare. The light of the star itself makes the star's dim planetary system nearly impossible to see. How would you like to be an astronomer who's constantly vexed by stars? Bummer. Fortunately, there may be a solution. It comes from NASA's Galaxy Evolution Explorer, or GALEX for short. an ultraviolet space telescope that has been orbiting Earth since 2003. In a new study, researchers say GALEX is able to pinpoint dim stars that might not overwhelm their own planets. We discovered a new technique of using ultraviolet light to search for young, low-mass stars, says David Rodriguez, a graduate student of astronomy at UCLA and the study's lead author. These M-class stars, also known as red dwarfs, are excellent targets for direct imaging of exoplanets. Young red dwarfs produce a telltale glow in the ultraviolet part of the electromagnetic spectrum that GALEX can sense. Because dwarf stars are so numerous, as a class they account for more than 2/3 of the stars in the galaxy, astronomers could reap a rich bounty of targets. In many ways, these stars represent a best-case scenario for planet hunting. Their low mass means they are dimmer than heavier stars, so their light is less likely to mask the feeble light of a planet. And, because they are young, their planets are freshly formed and thus warmer and brighter than older planetary bodies. Astronomers know of hundreds of distant planets, but very few have actually been seen. Many exoplanets are detected indirectly by means of their wobbles, the gravitational tugs they exert on their central stars. Some are found when they transit the parent star, momentarily dimming the glare, but not dimming it enough to reveal the planet itself. This new GALEX technique might eventually lead to planets, which can be seen directly. That would be good because, as Rodriguez points out, seeing is believing. And it just might make astronomers feel a little better about the stars. For more information about distant planets and the stars they circle, visit science.nasa.gov.